Hello, everybody. Good afternoon and good morning, and welcome to today's webinar, Armtec Engineering Top Picks, Case Studies and Design Review. My name is Janine Yetke. I'm the Director of Marketing for Armtec-Drainage Solutions, and I run the webinar program, and I'll be your host for today's event. We also have James Carter on the line, who is our technical moderator, and who will be running questions and answers at the end of the session. I will quickly go over some housekeeping items. At any time during the presentation, if you have questions, please enter your questions into the question log. We will get to the questions at the end of the session. As a reminder, attending the session will qualify you for a 1-hour technical informal CPD credit. For those who have registered directly, we will send out the certificate to the email provided upon login. For those who are attending as a group, please compile your list of attendees and send the attendance list with the required details to webinars@armtec.com. I'll start off with a brief introduction to Armtec. We are one of Canada's oldest and largest infrastructure companies, supplying a full range of steel and HDPE-based bridge and culvert materials, as well as soil retention, stormwater management, and precast building systems. Because of our convenient locations across the country, we are positioned to serve you wherever your needs are. We serve numerous sectors, from the municipal to forestry and transportation to commercial, retail, and residential construction. More about how we service these sectors can be viewed on our website or through discussion with one of our experienced sales representatives. We also have a centralized engineering department and regional engineers across the country who have the exceptional capability to fully support design and challenging engineered projects. Presenting today are Dominic Turner and Doug Leitch from Armtec's Drainage Solutions business unit. Dominic is a regional engineer for Armtec's Eastern region and national product coordinator responsible for the Haraton product line in North America. He is actively involved in the specification, design, and construction of projects including storm sewers, trench drains, culverts, and water quality solutions. Doug Leitch is our Manager of International Sales and has extensive experience in civil and mining engineering. In his 25-plus years with Armtec, he has been involved in the design and specification of an array of drainage and structural projects and has managed some of Armtec's largest mining and infrastructure projects in over 20 countries on 6 different continents. Both of them look forward to many questions at the end of the presentation, so please feel free to submit your questions at any time during the presentation. So with that, I will now hand off the presentation to Dominic. Welcome, Dominic.
Thanks, Janine. Okay, you should see my screen by now. So welcome everyone again to our webinar. Thanks for joining. So today we'll be presenting 2 very exciting projects that Armtec has been involved with and from the drawing table until the installation on site. So it was through the whole process of the project. So I will be presenting the first project, which is the Viau terminal rehabilitation at the Port of Montreal, in which I've been involved personally. So we've designed and supplied an innovative drainage solution that is perfectly adapted for seaports. And then I will hand over this presentation to Doug, that will talk about our second project, which is the Great Allegheny Passage. It's the rehabilitation of a concrete tunnel using a unique custom fit structure for tunnel relining. Very interesting project as well. So let's start with our first project, the Viau terminal. So in the next few slides, I just want to quickly go over the basics of linear drainage systems, and that's just to facilitate the comprehension and the nature of the project that I will present you. So here are some pictures of modular trench drains, so used in multiple applications. Those are from light duty to medium duty, so that includes LRT stations, parks, walkways, building entrances, driveways, parking ramps. And now in the heavy duty and extra heavy duty applications, that includes roads, industrial areas, service yards, ports, and airports. On this exploded view, you can see all the components of a modular trench drain system. So we can see the pre-assembled trench drain unit, which are composed of a 1 meter channel with a grate secured by a locking mechanism, followed by an optional catch basin with a sump to retain the sediments. The trench drain that we supplied at Armtec are the trench drain body, the channel, is made of thermoplastic and more specifically of polypropylene, which makes them very versatile. So there are several pre-molded outlets, like you see here on this end cap. And also we have vertical pre-molded outlets and several outlet capabilities integrated to the catch basins. We also have side connection capabilities with the trench drain and in order to produce elbows and T's in the trench drain. Let's continue with some basics on surface drainage. So point drainage is the most conventional surface drainage system. So it's basically water is intercepted at low points through catch basins, and those catch basins are connected to an underground storm sewer system. This works really great in drainage areas with steep gradients, so you can think of a road where a catch basins are installed against the curb with a sloping pavement. It is also often used in conjunction with linear drainage system in order to maximize the drainage performance. There are some issues that may occur in certain applications with point drainage. So first, it may be costly because the grading is complex, installation is time-consuming because of the deep excavation and a lot of structure to put in place. In practical, what I mean by that is less comfort for the user, so less aesthetic, mainly with pavers. Also, it may lead to inefficient performance. For example, ponding, as you can see on the right picture here. So the low points have shifted with the settlement of the pavement, which creates some pounding in front of the catch basin. Also, there can be blockage, as you can see in the middle picture. So the leaves accumulate at the low point, and then it kind of creates blockage on the grade. Also, increased maintenance costs. So it's because of the poor access and the extra structures. Deeper pipe invert that may enter in conflict with underground structures. Now, an innovative solution for surface drainage is the linear drainage. So water is intercepted along the entire trench drain run instead of just low points, and the interception rate will always be greater than point drainage. And this is due to the larger area covered by the grate, basically. It's cost-effective because there's less pipe work and the grading is really straightforward. It's just 2 slopes to be constructed. It works really great with large impervious pavement and also level and early levels. It may be used as a cut-off drain as well to intercept water flowing down a slope. You can think of it as underground parking ramp, for example. In summary, linear drainage system is more efficient at intercepting runoff water. So this is due to the grade area that is larger and also the shorter distance traveled by the runoff water in order to reach the drainage system. Pounding even is reduced or eliminated, and this is even with the aging of the pavement, after which the water is still likely to find its way to the drain. Shallow depth of construction. The grading is very easy. There's no diamond shapes to be done. It's just 2 slopes toward the trench drain. More economical because there are fewer components. Easy access along the entire length of the system. So basically we just have to remove the grate and we have a direct access to the system for maintenance. Eliminates the roller coaster effect for vehicular traffic that you may experience with point drainage. And last but not least, it's a very aesthetic solution that can be integrated to the landscape in a very elegant manner. Now that we've covered the basics, let's dive into the project itself. The Port of Montreal is the 2nd largest container port in Canada and 5th on the east coast of North America. They are expanding the Viau terminal right now, in order to increase by about 30% its container handling capacity. This project is divided in two phases. We've been involved in the first one, which was completed last November, and the second phase is to be completed in the years to come. So the design of the project, the phase that we've been involved with, was done by CIMA Plus, and the contractor that was awarded for the construction was Roxborough. In the design stage, we were asked if we had a solution to a drainage challenge that meets certain very specific requirements, which we obviously did. So here is an overview of the Viau container terminal. So you can see here the on-dock rail, and then at the back here you can see the access road to go from one terminal to the other. So we were looking for a drainage system to drain two on-dock rail terminals. So the first one is here, and the second one is here. So the red rectangles show the location of the required drainage system. So we were looking for an efficient solution to drain two on-dock intermodal terminals, which are paved area that are trafficked by container trucks and trains at the same time. Of course, since we're on a dock, there is no gradient, so the surface is perfectly level. And we had very small possible drop between the upstream and downstream end. We're talking about a few inches over 400 meters. So it was impossible to respect the minimum slope with a conventional catch basin storm sewer system. We were looking also for an easy access for maintenance, and the design must be with just one single outlet at the end of the system, and that was to avoid the use of a parallel storm sewer pipe. And also we were looking, of course, for a sustainable solution that can handle the loads of heavy vehicles that you find around ports. In the next few slides, we will review the hydraulic design and selection process for this project. So the system that met all the criteria was the Recifix high-cap F flood drain system that is manufactured by the company Horton, and Armtec is proud to be the exclusive distributor for North America of the systems. So high-cap stands for high capacity, which is different from the conventional trench drain system we've seen earlier. And that was required because the project, you convey so much volume of water over 400 meters. So that's why this kind of system was necessary. The internal width of the first system, the F300, is 300 millimeter, so that's the internal width, and the second one is 680 millimeters. So those are the two largest trench drain systems that we can supply at Armtec. Both systems were to be 400 meter long. Each section of the F300 measure 1 meter and 1.40 meter long for the F680. The channels are made of high-grade polypropylene, which makes them very resistant to numerous chemicals, such as the hydrocarbon. The grade was made of ductile iron and embedded in the concrete, so it's not a removable grade, which was necessary to be durable with the high load. And also the system is designed for the highest load class, which is the F900 kilonewton. Okay, this illustration shows different models of Recifix high-cap systems. So number 6 and number 7 are the sections that we did provide for the Port of Montreal. And I'd like to draw your attention on the item number 10 in the middle. So that's a catch basin. That was, we placed those units every 50 meters, and that was in order to provide an easy access for maintenance. Armtec can run a hydraulic analysis in order to recommend the size, which is what we did for the Port of Montreal. So the Horton design software that we used is based mainly on tree form. It gives us the outlet flow of the trench drain. And then we use the Manning's formula and energy equation to calculate the hydraulic grade line throughout the length of the trench drain route. So for our project, we've had the designer to give us some hydraulic parameters. So that includes catchment area, the runoff coefficient, which was 0.9 in that case, the slope, which was 0 in our case, and the design rainfall intensity, which was 150 millimeter per hour. With that information, we were able to provide a recommendation on the size of the system to be used for each run, and also the outflow rate so it can design the downstream structures and the hydraulic grade line inside of the trench drain. So here's a hydraulic analysis for the first system that confirmed the sizing. So the filling level is 89%, which is perfect, as we aim for about 90%, and this is to compensate for the sediment accumulation between maintenance. We did the same for the second trench drain run. So in this case, the channel was filled to 82%, which confirmed again that the sizing is adequate as well. Now that we have identified the solution, determine the size and configuration, it's time to build it. So I'll show you some nice pictures that show the entire installation process that was used by the contractor. So the first step is to excavate for the foundation. Right after, they did the foundation, which is composed of compacted crushed stones. Once the foundation was done, the formwork and rebars were put in place so they can do the concrete base. So as you can see, they used a full formwork on one side and a small one on the other side, and that's so they can have access afterward to put the trench drain system between the rebars. They did the concrete pouring in 3 steps. So the first one was the base, and after another one for the lateral concrete, and another one to finish with the top concrete. So here we can see them pouring the base. It's preferable to smooth the surface, and this is in order to ease the installation of the trench drain unit afterward. This is the result after the curing, and now the base is ready to accept the trench drain unit. This picture shows a recess, and this is to accommodate the sump of the catch basin, the access manholes, for future maintenance. Then it's time for the trench drain lane. So I'd like you to notice how huge are those units on this picture beside these gentlemen. So this was again necessary because we have 400 meters of trench drain and just one single outlet at the end. So you have a high volume of water to convey, over 400 meters. Also notice how the grade is small compared to the system. And it's still very, very efficient to intercept water. And that's because you have to think that this 28 millimeter wide grate is 400 meters long. So the area that it covers to intercept water is quite large. Straps were used to secure the trench drain and prevent them from uplifting with the concrete pressure. Now it's time to finish the formwork. So I like this picture particularly because we can see how the stretch is long. So as I told you, it's 400 meters. So on that picture, we can even see the end of it. To accommodate the wide temperature differences, the contractor was asked to build some expansion joints every 20 meters, and also control joints every 5 meters to control the cracking. It's important that all joints should coincide with a channel-to-channel joint. So an internal formwork, like you see in the picture, was required to in order to put in place the expansion joint. So what they did is they started by pouring the right side here, and then after 24 hours they could remove this internal formwork and then do the pouring on the other side. So that's how it was done. We recommend to use a string line, and this is to ensure perfect alignment of the grate throughout the trench drain, and also use protective tape on the grate, and that's to prevent concrete spillage on grate. And this is a picture of the formwork completed. So now it's ready for the lateral concrete pour, which we see on this picture. It is very important to vibrate the concrete, and this is to ensure that all the voids are filled. And then we smooth the surface. This is a particularly important step because this is the surface that we're going to see at the end of the project. And then we were 24 hours, and then we can start removing the formwork and socket the joint, the control joint. Now let's have a look at the final result. The installation of the trench drain run was 3 weeks for each run, and that is about 25 meters a day, and that includes all steps from the excavation until the pavement adjacent to the trench drain. Some more pictures. Now I'd like to share with you the challenges that were faced during the installation. So the first challenge was an angle was to be done in one of the trench drain runs. The angle was close to 15 degrees. So I'll explain in more details in a few minutes. The second one was the two existing manholes were interfering with the trench drain. So we had to come up with a solution to address that. And also, despite the fact that Harton is a worldwide company and they have done several similar projects around the globe, this was the first project, the first Harton trench drain project in Canada. And being the first project, of course, the contractor faced some early challenge, but it went pretty smoothly, fairly quickly. Roxborough is a great contractor. They've done a very great job on this project. And Armtec and Harton have been very supportive during the whole process. So we did a pre-construction meeting, several site visits, and also we helped finding solutions to the challenge we faced. So this is the angle that I was talking about. So this was the first challenge. We needed to change the direction, and that was in order to follow the rail track. And we were able to do that without any special parts. So the channels joint can accommodate a certain angle, so that varies according to the size. Alternatively, we could have done a smooth curve by spreading the angle over multiple joints. The second challenge was the interference with two existing manholes that are insulated, as you can see on this picture. So this was due to a relocation of the trench drain. I'm not sure exactly why they relocated it, but anyway, we had this interference problem. So what we did supplied a solution with special end caps that were able to channel in a 300 PVC pipe with a watertight connection for a few meters, just so we can clear the manholes and then continue with a trench drain. To conclude, we did provide an innovative solution that consists of a high-capacity trench drain, two stretches of 400 meters each. There was just one single outlet at the end of each system. And it was a very high-performance system, despite the fact that the grade is very small. Like I said, because it's 400 meters, it's very efficient. It's about 4 times what it would be with conventional catch basin. I mean, the area covered by the grade. It was a perfectly level finished surface, no slope at all. The installation took 3 weeks per system. And contractor, designer, and customer were all very satisfied with the product. So this was a very successful project. So I'm done with my part. So I will now hand off this presentation to Doug, who will be presenting the second project, which is the Great Allegheny Passage. And it's a very, very interesting tunnel relining project that Armtec have been involved with. So I'll let Doug explain the details. Welcome, Doug.
Thanks, Dominic, and welcome to the second part of today's webinar. My name is Doug Leitch, and I have the pleasure of presenting a 2015 project Armtec was involved in called the Rehabilitation of the Pinkerton Tunnel, which was done for the Somerset County Rails to Trails Association. Over the course of the presentation, we're going to review the background details. We'll spend some time on how the solution was selected. We're going to look at the client's needs and the design criteria with which we were proposed, how the structure was installed, and finally, how everything came together to produce a very economic solution. Rails to Trails is a U.S. program to convert abandoned rail lines into a nationwide network of biking trails. One of the most picturesque of these is the Great Allegheny Passage, which twists through the Appalachian Mountains from Washington to Pittsburgh. Near the pretty town of Somerset, the trail crosses the Castleman River, and here's where the story of our project begins. So if we take a look at what we have here, this is the Great Allegheny Trail here from Washington to Pittsburgh. Just crosses the boundary line between Pennsylvania and Maryland. Here is where we're located, okay? And we're going to blow that up a little wee bit. And this is Somerset County. And we're going to blow that up a little bit more. And you can see right here, this is where the actual trail moves. The trail is brown, swings around here. And the blue, of course, is the Castleman River. So our project site is right here. And when the bikers came, this is what they would see. They crossed the Castleman River. Bikers would cross the Castleman River, and here is where they basically end up. Okay. Until the fall of 2015, bikers crossing the Castleman were met by detour signs around the 100-year-old dilapidated Pinkerton Tunnel. Bikers traveled 3 kilometers around the mountain as spalling walls and roof failures had made the tunnel unsafe. In 2014, the Somerset Rail Association hired Pittsburgh-based engineer Garnet Fleming to prepare a rehabilitation program for the 270-meter-long tunnel. They worked along respected Columbus, Ohio contractor GeoBuild. Garnet Fleming had an idea for a steel lining solution and asked Armtec to prepare a proposal. The owner and engineer had 8 design requirements and constraints that they had to match. Those included maximizing the lining size, which would of course minimize the grout spacing in between. There were to be no interior obstructions in the course of building that. Now when I mean no interior obstructions, that means this area right in here, and I'll tell you why that was a little bit later as we move on. Of course, one of the other constraints was there was very limited access. It was the site was basically landlocked by the Castleman River. We had to rehabilitate the roof and the side so it was safe for the bikers to go through. There were certain loading requirements that were required. Very important was the timing. We had to finish the project by autumn because that was a very busy season for the bikers. A lot of them came to see the colors of autumn that came in through the Appalachians at that time. There was a service life requirement. The tunnel was about 100 years long, and they were looking for it to last for another 50 to 75 years. And of course, they wanted to find a good low-cost solution. The steel proposal included a structural plate lining placed inside the existing 9-meter span by 7.2 meter high tunnel. The annular space between the concrete and liner was to be filled with grout. Armtec's proposal was to line the tunnel with corrugated structural plate. Structural plate is strong. It can be curved to meet all the needs and versatility that's required to meet the tunnel size. And it's easily moved to remote sites. Now, if you look at this particular picture here, you can see this is the tunnel. Excuse me. This is the existing bridge across the Castleman, and you can look. If you look here, you can see exactly how tight this particular tolerances were. Now that says the tunnel was installed, and those are the kinds of things that the owner was very interested in being able to obtain. Regarding the interior obstruction size, he didn't want any. Armtec selected its deep corrugated bridge plate product. Its corrugation profile is much larger than conventional multi-plates, making it stronger and stiffer. So the bridge plate corrugation is 400 millimeters from crest to crest and 150 millimeters deep. Conventional multi-plate is 150 millimeters crest to crest and 50 millimeters deep. So you can see this is a comparison of the two products side by side. The longer, deeper corrugation makes the structure almost 10 times stiffer than conventional multi-plate. And that stiffness was very important because that's what was needed for that particular structure to sit there on its own without additional strutting and bracing that would impinge on this particular area right here that was needed to be open during the construction. The other great thing about multi-plate is it can be curved. It's curved to any radius that's necessary, and we had to do that to meet that. And finally, as we get through, you can see how the structure was built outside. It was assembled into 6-meter rings at the ends and eventually slid into place on special footings. Once inside, the panels were joined with internal connection plates. Loading was limited to the dead load of the concrete fill used to repair the roof collapse and the side pressures from the grout. This was probably the largest hole that was in the roof. This is approximately 6 meters long and almost 3 meters deep. Now that had to be filled with grout after the liner was installed, so the liner itself was responsible for holding that dead load. Also, it had to be able to withstand the loads from the sides of the tunnel, and finally it also had to be able to withstand the grouting pressures from the side. The timing, the tunnel had to start work in May, and there was a 4-month window to finish by September 1st. These were all the constraints that were given to us by the client. Again, they wanted a design service life of 50 to 75 years, and of course, find us a good economical solution. Let's look at how the requirements that we had and how Armtec solution matched the needs. As I showed you, the site was remote, buried deep between the steep Appalachian hills and constrained at both ends by the Castleman River. The solution was to widen the existing bridge and strengthen it to the point that lightweight equipment and materials could cross. So if you see in this particular picture now, generally speaking, this part of the bridge, this is going over the Castleman River, was good for pedestrian and very, very lightweight traffic, including small cars and bikes and so forth. The actual access bridge was extended out by these structural members, was widened out and strengthened such that lightweight equipment could get across and work at the job site. So that was part and parcel of the job, but it was a great money saver for access. If we combine that with the bridge plate comes in pieces, so these pieces were generally buried across the bridge and left at this end of the tunnel for assembly later on. Regarding the loading, the bridge plate was designed using AASHTO LFRD, basically to withstand the dead loads from the onfilling of the roof cavities. It also withstood the grouting pressures from the sides. In addition, as I mentioned, that the sections were pulled and slid into place, so there was a fairly large tension on the ends of each plate, and there was a serious bolt shear that had to be looked at. But in the end, it was the actual stiffness that was required to maintain this space right here during construction to make sure it was completely open. Now the reason that they wanted it open, that the owner wanted to be able to assemble and grout at the very same time, because he was very fearful that a 4-month window couldn't be met. So they wanted to ensure that both, if necessary, both the construction and the grouting could go on at the very same time. So they weren't going to allow any kind of bracing or anything that would inhibit the grouting should that become necessary. All were aware of the importance of the timing, and that had to be done by autumn, as I mentioned, in order to meet the fall colors. So the timing was set up was in May would be a mobilization period. Okay, so in May, some of the structure components were shipped. June and July was set aside for assembly, which was this period here. You can see the guys putting the plates together outside. And finally, into August was set aside for the grouting procedures. The only other concern that Armtec had to ensure was that the zinc coating plus the sacrificial steel that was put in there was sufficient to give them that 50 to 100 year life expectancy that they were talking about. Okay, so when we put the whole selection process together, you can see how this turned into a very economic solution. First of all the equipment that was being asked to be there was lightweight materials. It didn't cost that much to be able to get them on site versus some other alternatives. There was minimum clearance for the grout savings. No interior obstruction as required, so that if indeed they had to do both operations at once, it could be done, all of which made immediate economic value to the county. It was less cost to do it, generally speaking. On the other side of the coin, what they wanted to ensure was that they got the promotion that would be necessary, or got the promotion from the bikers in the autumn season. They wanted to be able to have the tunnel open. It promoted the use of that particular trailway, and would all generate long-term economic value. So all of these things put together fit exactly into the requirements of the owner, and that's what the engineer had specified for us to have. So let's take a look at the actual design and installation. The engineer, Gannett Fleming, actually laser measured the inside of the tunnel and requested a tolerance of 100 and 150 millimeters between the outside of the liner and the inside of the existing tunnel. Now, we've done a lot of linings before, and never have we really had, and in a lot of cases, you're not really sure what kind of tolerance that you have, so you usually undersize the liner to take account for that. In this case, we were very sure of the kinds of tolerances that we had, and we're able to curve all the plates almost exact in order to meet the requirement. This was sort of probably the least kind of tolerance we've ever used, particularly for something as big as this particular tunnel, over 8 meters span and 7 meters high. So if you can look at this picture right here, you can see this is actually the outside bolt hole of our bridge plate structure, and here's the inside of the wall. You can see exactly how close that is. And in some cases, when we were pulling the structure through, the bolt hole actually scraped the outside of the concrete wall. Things were that exact, but at no time did it ever get locked up. It was probably the smallest or the most exact tunnel lining system we'd ever done before. This is how the construction took place. Excuse me. GeoBuild poured the footing, poured a concrete footing, and embedded in that footing was the steel channel. And on top of the steel channel was a poly slider plate that was lubricated. And you can see this is the footing of the channel here. And as these sections were made, they were each made into 6 meters long. That was 5 actual rings of structures made 6 meters. They were slid down the full length of the tunnel, some of them as much as 270 meters. and then they were joined with special internal connection plates. Along the side, you can see here there was a drainage blanket that was set there that picked up any water that might seep through the existing cracks of the tunnel. The 6-meter lengths were, excuse me, were all assembled at one end of the tunnel, and you can see that the bolts were torqued on the inside and the outside at the same time as it went through the. And again, this picture down here, guys working on the inside and guys working on the outside. As each 6-meter section was completed out here, it was pulled, some of them as much as I said, 270 meters down to the other end, connected by these pre-curved steel internal connections. And at the end of the day, we had made about 40 to 45 6-meter sections that covered almost 3 football fields of liner. Once a liner was assembled, the grouting procedure took place. It was the space was filled with low-density rigid foam, and in order to do that, the contractor drilled 20-millimeter diameter holes into the side of the liner plate. That's what this gentleman here is doing. He's drilling these holes. They were spaced around the circumference of the tunnel. This at 1 o'clock in various locations, 1, 3, 9, 11, and 12 o'clock. And then the fellows afterwards came along and they inserted the nozzle into the holes and filled the space in between. Now this again was all part and parcel of being able to use lightweight equipment. Everything that was used to grout that space came in the back of a truck. And this is it right here, okay? It's a 2-component system, and that was mixed together at the nozzle and shot into the space. And the foam expanded, and you can see it here. This is at the end, and it filled that grout and expanded and filled that space up very well. Now, it was interesting how they checked to see if it was completely full or not. This material comes out at a fairly high temperature, so they used a temperature measuring device aimed at the wall to see to make sure that all the voids were filled within it. If there were spots, they'd simply drill another hole and fill those up. It was certainly an economic solution, so let's take a look exactly how that money was saved. One of the interesting things was that at one point, someone had actually considered using regular grout, and that would have required the transport of some 300 to 500 cement trucks barged down the Castleman River and pumped that grout probably 150 meters to the release nozzle, so there was a huge saving there. The strength and stiffness of the bridge plate did indeed allow them to make that clear span opening, and provided the overlap of assembly and grouting should that have been necessary. Again, that was a timing issue, but in terms of dollar value, that was very important to the owner to ensure that that was done. And both the bridge plate and the tunnel, bridge plate tunnel and the expanding grout were strong, lightweight, mobile, and they were all able to move easily across this bridge to get to the site. So if you look at the economic benefits, it's interesting how the two components basically fit together in a very similar manner. They were both consistent and with low-cost alternatives to get across the Castleman, first of all. Assembly with lightweight equipment, again, both pieces of the puzzle were included. Both allowed for simultaneous assembly and grouting. The bridge plate matched the shape very well, and the grout and the flowability of the expanding foam was filled the void very easily. Both were speedy installation, and both met the service life, all adding up to a very low-cost alternative. So in summary, we started out with a 270-meter long tunnel requiring rehabilitation. Bridge plate was used to reline it. The maximum space between the reline was 100 and 150 millimeters, saved a lot of money for the owner. 6-meter sections were assembled outside at the end of the tunnel, pulled into place. The rehabilitation was completed in just 3 months, and the bridge plate liner assembled in just over 2. It was indeed a very economical solution. So thank you all very much for your time.
And thank you, Dominic and Doug, for your presentations. And for everyone on the line, thank you for taking the time today, especially during the busy holiday season, to join our webinar. We hope that you enjoyed the presentation. Our question and answer period is coming, so please continue to submit your questions. We'll be happy to answer them. First, we'll go over a couple of housekeeping items, and please stay tuned for our questions and answer session in just a minute. Dominic and Doug's contact information is shown on the screen, so should you have any further questions on the projects they presented or other projects coming up that they can assist in, please feel free to reach out to either of them. They'd be happy to answer your questions or connect you with a local representative near your project location. Today's presentation is the last in our 2016 webinar series, and we hope you enjoyed it. We look forward to you joining us for next year's exciting lineup, which will cover topics such as stormwater treatment, bridge rehabilitation, and mining solutions. You can follow us on social media on Facebook, LinkedIn, and if you know someone who was unable to make it to today's webinar, or if you'd like to view it in the future, you can go onto YouTube and it will be posted in the near future. You can also get all of the latest on Armtec by following us on our website, armtec.com. We do value your feedback, and at the end of the webinar, there will be a quick exit survey. We would like to know what you think of this event. Question 6 will ask if you're interested in receiving more invitations for Armtec webinar events. Due to strict Canadian anti-spam legislation, we are required to have your consent to receive future invitations for webinar events. So please be sure that you don't miss out. Please choose yes on our exit survey. If you choose no, you will be permanently removed from all emails and future webinar announcements. So please choose yes. Thank you again for joining today, and we will now move into the question and answer session, which will be moderated by James. So please continue to enter your questions into the question log, and we will get to them. Thank you. Over to you, James.
Thanks, Janine. So just to keep everyone flowing here, I think what I'll do is I'll actually start with the Allegheny Passage questions for Doug, and then we'll go back to the earlier ones. So the first one, there's a comment here. It says, I understand from previous webinars that in order for flexible plate to perform, it needs even pressure and proper fill quality, et cetera, but in a reline we don't appear to have control over this. Can you explain how the engineering principles might be a little bit different in a reline? Are you trying to reinforce the total structure so that rigid concrete does not fail at all, or are you actually accounting for point loading if the concrete does fail onto the structure?
That's a good question. Actually, the design was not to take the complete load of the tunnel. We were advised that the concrete itself in the existing tunnel was going to take most of the existing dead load. But however, the space that was there, the huge cavities that had to be refilled, the liner had to take that. And so that was part of the design. It is the same in one sense that it's a flexible structure and it gathers its strength from the backfill around it. In this case, the backfill, however, is not soil, it's the grout. So it still operates as a flexible structure. It did take the dead load of the material that was used to fill the cavities, but not the total load of the structure above it, or excuse me, the total load of the earth above it.
Excellent, thanks. Another question here, when grouting the liner, how far apart were the series of 20mm diameter holes?
Those holes were set on a spacing of approximately 1.2 meters, and they were both up at, so it's sort of like a grid, a 1.2 meter grid.
What is the weight capacity of the poly used?
The weight capacity.
Of the grout.
I'm not sure I understand. Weight capacity.
Or the
Yeah,
bearing
well,
capacity.
I'm not. Oh, okay. The strength. Oh, okay. I think the question is probably the strength. That was about 5 MPa, 4 to 5 MPa yield strength grout. It wasn't really high, but that's about what it was. So in that order of magnitude. 4 to 5 MPa.
There's another one here. Were bulkheads used in grouting to control longitudinal flow of the foam?
That's a very good question. Very good question. They were correct. At the ends of the structure, the foam that was used was just slightly different. It wasn't nearly as flowable. As they came to the ends, they used a stiffer type foam grout so that it didn't. The actual angle of repose, I believe, on the flowable grout was something like 38 degrees. But when they got to the ends, they used something that was a little bit tighter. I don't remember exactly what it was, but they did use a combination of a bulkhead and an expanding grout that wasn't quite as high of an angle of repose. And then once they had the bulkheads, they took the bulkheads off and refinished the end to make it look what you saw in some of those pictures there.
Excellent, thank you. Were there any issues with sliding the pre-built structure into place? Did the track actually do its job?
As with anything, everything doesn't go exactly as one would hope. So I would say there were some issues with that originally, but once they got them straightened out, it worked quite well. There were some minor issues beginning to get those plates slid, or excuse me, to get those 6-meter sections pulled through.
Mm-hmm. Excellent.
Yep.
There were a couple of questions that came in. People just trying to clarify the slope. So what was the invert slope of the trench drain system at the port?
Yeah, that's an interesting question. There was no slope at all in this system, so all the trench drain units were all the same depth, and the finished surface was perfectly level, so everything was level, the invert and the surface. But despite that fact, calculation and also experimentation show that the slope has no significant impact on the trench drain performance and the capacity of the trench drain. I have personally observed, by the way, our design was made with a zero slope. And I have personally observed a trench drain in action at the Port of Montreal after a rainstorm. And as expected, there was just a small trickle of water at the invert after just a few seconds after the rainstorm. So the water flows very well, even if there's no slope. The trench drain is different from pipe, so you don't necessarily need a slope in order to be efficient.
Excellent. There's always questions about snow and ice, which is interesting. This system, I understand, is done quite well in places like Moscow. So I guess there's lots of proof there anyway. But this one's quite specific. For a linear drainage system, if during cold conditions the drainage system becomes full of ice and snow, how does it function, and also how does it respond if there is a very quick temperature change, i.e. a heavy temperature rise with heavy rain?
Yeah, okay, that's a good one, especially in our weather in Canada. We know we have some harsh winter in certain parts of the country. Well, this system, that was one of the first questions that I had when I was introduced to this product line. And I've asked a lot of questions because Harzen has a lot of experience with Russia. So in Russia, they have, in Moscow, they have a very harsh winter, and other places in Russia. So basically, the explanation to that is, yeah, in fact, there might be some water that will freeze in the system, as it would be on the surface of the road. But since we do use road salt and a lot of de-icing solutions, then that is in order to remove that ice from the pavement, which will also work inside of the trench drain. So it will be probably the first thing that will freeze, but it will also be, since it's up at the surface, it will be the first thing that unfreeze as soon as you have the water unfreezing, the ice unfreezing and turning into water. So there's no issue. The only thing you want to make sure is that the outlet of the trench drain has at least a 1% slope in order to the water to flow efficiently out of the trench drain system, and you should be good with those systems. There's no issues. They have been used for years in Russia again, and also in Canada. Still, we have a couple of experience in Canada, and it works. It works during winter. There's no issue there.
Thank you. I just checked online. Moscow's -11 today, but I believe they go to -30 quite regularly. So.
Oh yeah. Oh yeah.
So with shallow bury of the system, how do you prevent ice buildup in the drain during winter and spring? So we kind of covered that one.
Yeah.
There's another one about concrete encasement. What is the lowest strength of concrete encasement that can be effectively used with an asphalt road structure?
With asphalt, we recommend if there's traffic, we recommend 35 MPa. It could be 25 if it's a pedestrian area, but as soon as you have traffic, we recommend to go with at least 35 MPa with the concrete encasement. And the dimensions of the concrete encasement is going to be somewhere from 100 millimeter up to 200 millimeter all around the trench drain, and that will depend on the load class, so the kind of traffic and the exact application in which we want to use the trench drain.
Excellent. And now I'm going to jump back to Doug's, because that seems to be it for now on Montreal, on the Port of Montreal. But there's some more follow-up questions on Allegheny Passage. What retention of sediments was found? Oh, sorry. This is actually trench drain. What retention of sediments was found in the trench drains at zero slope?
If there is sediments building up in the trench drain, that's the question?
Yeah, that's right.
Okay, yeah, well, in every trench drain, there will be some sediments built up. And this is why it's not that important to have slope, because with pipe, we tend to want to have a minimum slope, and that's in order to have a cell cleansing capability of the system itself. With trench drain, you'll have to entertain that, to maintain that at some point. Exactly as you would do with catch basins. So we recommend to clean that up once a year. But really, if you have a 0.5% slope versus no slopes, there is not really a difference between those two situations in terms of how the sediment will build up in the system. You won't get, it's not a 0.5% slope, pre-slope system that will justify that you don't need to entertain the system. It won't change too much a thing, and that's the same in terms of performance and capacity of the trench drain itself. So it's quite different. I don't have a lot of time to go into too much details why it is that fact, but we can't. It's not the same as a pipe, because you have water coming from everywhere. So it's not a nice flow that could be self-cleansing.
Excellent. So that we're at 10:02, so we're going to wrap up now. Big thanks to Dominic and Doug for today's presentation, and of course many thanks to our audience for joining us today. Again, please take 30 seconds to complete the exit survey, and be sure to choose yes for number 6, so we can stay in touch. If not, unfortunately, due to anti-spam laws, you'll never hear from us again, and we don't want that. There is also number 4 question. You can indicate whether you'd like a technical sales rep to get in touch regarding a project. Obviously, I'll talk to you about any projects you have. And with that, I'm going to sign off and wish everyone a wonderful holiday. And we look forward to seeing you again in January for more webinars.